My name is Leah Sloan. I'm the Director of Professional Development, and I have with me supporting this session, Mark Dozier. He's one of our customer success managers based in Texas. I'm actually in the Chicago area. So the launch, Mark launched the poll again, so give everybody a chance to answer that really quick question. At what age do most babies start to walk? And we'll share out the response to that in a minute. Mark will share those results. Looks like we have a lot of people who've answered. Oh, interesting. You know, I'm seeing the results come up and it's exactly what I would have guessed. But Mark, you want to share that?
All right. So if you said 15 months, you got that one right. Wow. Personally, my son is 20 months and I don't remember when he started. So I think I got that one wrong.
I think I would have guessed 12 months because that's about the time both of mine started walking. So yeah, fun little fact. All right, so I'm going to turn it over. We have Dave Reinke with us. His session is The Journey Revisited, my first year with CodeHS. He's got an amazing session planned for you all, and I'm going to let him take over. Thanks, everybody.
Thanks, Leah. Good morning, everyone. Again, Dave Reinke here. As Leah said, I'm a teacher, my first year teaching with CodeHS this year. I teach at Nazareth Academy High School in the suburbs of Chicago. Today's lesson, we're going to talk a bit about more of my experiences this year. And actually, hang on a second. Can I get my slides to move? There we go. Great. Talk a little more about my experiences this year. You know, learning lessons learned, do's and don'ts, things that I might do differently next year. And as well as how our school is adopting a new CS curriculum as a result of our experiences with CodeHS. So I'll do a quick introduction of my background. I have a kind of non-traditional path to this point in my life. Then we'll talk a bit more about what we did or what I felt worked for preparation and planning for the classes I taught, how we dealt with lesson cadence. We teach a block schedule at my high school, so I see students every other day for 80 minutes. That requires a little challenging lesson planning. Then we'll shift gears, talk about grading and academic integrity, everybody's favorite topic. Yes, I think cheating and getting code off of the internet now is much easier than it was when I was taking computer science, right? So something we have to worry about. Then talk about how my high school is now adopting new curriculum pathways now that we have the full portfolio of CodeHS courses available to us. And then I'll wrap up with some features that I felt were real valuable for me this year, and some that I pushed off to later and may never use. I just want to give a sense of kind of where I felt things were working and weren't working. So anyways, that's the path, that's our agenda. So really quickly, I was born at the right time in history. I was very fortunate to go to a high school in the early 80s where there was a computer programming class available. And I took that class and my computer science teacher literally changed my life. Within 2 weeks of learning how to program, my first 2 weeks was, this is what I want to do the rest of my life. And I focused on that throughout my college career, got a master's degree in it, spent almost 30 years in industry, was fortunate enough to build some businesses and sell and retire early. I retired for exactly 2 months. And then I got really bored and felt I needed more purpose in my life and thought, you know, I want to give back a little bit, and so I became a teacher. And this is my 5th year teaching, 3rd year at Nazareth Academy, and my 1st year as a full-time computer science teacher. So that's my non-traditional journey. So I have both an industry background as well as a beginnings of an education background. Just again, to give you some biases to kind of what courses I taught this year, it was the web design class, APCS principles and APCS-A. I had 4 semester sections of web design, 2 sections of principles, and 1 section of A. We had roughly 100 students, maybe a little more than that, taking computer science this year, and our high school is only 800 students. So a pretty large percentage of students are interested in computer science, and actually even higher number is going to be enrolling next year as we expand the enrollment. I'm going to be a very busy man next year. All right, so preparation and planning. So you kind of break this down into kind of what you want to do before you start teaching the class, what you want to do while you're in the middle of teaching before each unit, and then within the unit, what you want to do before each lesson. My most important advice to you is before you teach a class, take the class. Enroll yourself in the class inside of CodeHS. You can do it, it's very easy, and take the class. You don't have to do every single exercise, But the key thing here is understand the flow and the dependencies and knowing what comes for, knowing the sequence of lessons so that you can do proper foreshadowing as you're teaching the class, right? And I use that taking the class while I'm taking the class, I'm creating a course plan. I'm kind of meticulous about things. I plan things out to the day, right? Before the semester even begins, before the year even begins. It never works out that way, but at least I have a plan to go back to and adjust. And then the last thing I would tell you as a first-year teacher is stick to the script. What I mean by that is CodeHS gives you a lot of capability where you can go in and add units, reorder units, change lessons, sequencing of lessons in units, sequencing of activities and lessons. For the most part, I stuck with the script. In web design, I did change the last unit. I swapped it out and put a unit of bootstrapping in, but that's about the extent of what I did. And maybe I resequenced a few exercises in some of the lessons. But I think stick with the script. It's a good curriculum. Don't try to modify it too much to start with. I might get a little more experimental this next year now that I know what I'm doing and I understand, having taught it, where the potholes are and so forth with students, and maybe augment a little bit that way. But I would say if you're starting from scratch with a new course, trust CodeHS. They got it. They got the sequencing down just fine. Now, as you get into teaching the class, before each unit, I've made a best practice out of reviewing all the lesson plans for the unit. Don't do the lesson plan one at a time, but read them all at the very beginning as you prep the unit schedule. This will help you kind of think about like how much time you want to spend on each lesson. Some lessons are easy, some lessons are more challenging, more time consuming. So, reviewing the lesson plans help you understand that. And then the other thing you want to do before the unit is take the test. Take the test yourself. If you don't get 100%, right? Well, you're the teacher, right? The students are going to be even more challenged. At that point, you have a sense of the level of knowledge required to answer some of the questions on these tests. I find that some of the tests were very challenging for my students, especially in the AA class, the AP CSA class, and I had to kind of dial back the level of knowledge for those tests. So by taking that unit test at the beginning of the unit, I'm able to understand where the kids need to be at the end of the unit in order to be successful on that test. And I'm also understanding kind of what questions I felt were maybe too tricky or required too deep a level of knowledge. And I was able to kind of modify or fork the test to create something I thought was more appropriate for the level that my students are at. And then lastly, finalize exercises. What I mean by that is which ones are you going to do in each lesson? Which ones are you going to teacher grade? Which ones are you going to auto grade? That kind of discussion. At my high school, we have a policy that on average, we're only supposed to give about a half hour of homework a night for our class. Now, remember, our students see each other, we see them every 2 days. So I can't, initially I was assigning all the exercises from CodeHS to my students and it was overloading them. So I had to back off, I had to dial that back and only pick which select exercises to assign and then make the other ones optional challenges for students who were more advanced and able to work more quickly. And then before each lesson, review the script, decide whether you're going to use the video, whether you're going to teach with the video slides or do a hybrid. I'll talk about this in a little bit, but I chose hybrid more often than not, where I'm showing the video, pausing it, having a discussion, maybe going out to the examples, then going back to the video again. I found that to be most effective in most of my classes. But again, each teacher is going to be, and even in each course, even each lesson, you might make a different decision on that. And then finally, obviously, prep handouts, examples, and demos, things you normally do. Okay, lesson cadence. So you're in the class, you're in a lesson, you're in a session. I have a block schedule, like I mentioned, 80-minute blocks. I see my kids every other day. So I can't do one CodeHS lesson per class. I can't because there's not enough classes, right? Not enough days. So I have to do multiple lessons sometimes. Sometimes I even do 3 lessons in a block. And so my normal cadence is do a review part, do some instruction with the lesson, give them some lab time, and then iterate that for each lesson I'm teaching, and then have an exit ticket activity. In the review session, I did a lot of different types of review. The 2 that I find myself doing the most for my AP classes, I always use the question of the day as a bell ringer. So as the students entered the classroom, the question of the day was on the projector. The students knew to get their MacBooks out of the locker or the chest we have, log in, do the question of the day while I'm taking attendance, things like that, right? And then we go through the question of the day. I thought that was a really good way to get the juices flowing. The other thing I did more frequently was a collaborative group debug. And I'll go through some slides to show you how you do that. but effectively I would create a buggy program and have the class help me debug the program online using the CodeHS tools. You could do, looking at previous exercises. I did that a couple times. You can do a sandbox demo where I created my own demo in the sandbox for the students to get them going, or even, do some quizzing either with Socrative or Kahoot or something like that. All right, then you get into instruction, right? And this is where I talked about, are you going to use the video? Are you going to lecture to the video slides? Or are you going to do a hybrid? I found with my web design course, I relied on the video more frequently. The videos for the web design are really, really good. I really not much augmentation needed there. For my principles class, I found myself doing more hybrid, where I'd have the video and then I interrupt it, do some chalk talk on the whiteboard, or pop open a sandbox and manipulate some stuff, show the examples. And then for my APCSA course, I did mostly lecture. The class size was small. I had 12 students. And I know Java very well from my professional career, so I felt like I could teach and explain it better than the video could. So I would take the videos, I'd take the slides, usually use the slides. Sometimes I'd copy them and make adjustments and then teach that way. Again, every teacher is going to be a little bit different based on your background there. The other thing I would strongly suggest is each lesson comes with examples, and the video sometimes will walk through the example with the students. Well, there's no reason for you to walk through the same example they just saw in the video, right? What I do with the examples is I break them, make mistakes, show syntax errors, cause errors to occur so that the students can see errors that they're going to run into when they do the exercises, right? So, leave out a semicolon if it's a Java class, or don't do the right indentation if it's Python, or if it's a web design class, HTML can be very finicky when it comes to spaces and characters and things like that. So, forget leaving out a space, and all of a sudden a class name becomes a tag name and it gets all goofed up, right? So you can do things like that to show students how errors pop up, and then help them see the error message and interpret the error message and then fix the example, right? So that's what I use the examples for, is to kind of show mistakes. And I also did extensions on the examples too. Like, okay, let's make it a little more complicated. Let's do some more than the basics. So use the examples in that way. And then, of course, make sure the students understand the examples are there for them to refer to when they're doing exercises. Have a tab open with the example, have another tab open with your exercise, so you can go back and forth and see the way the code works as you're trying to work through the problems. Lab time. Basically, this is time for students to do the work in class. With an 80-minute class, it's nice. Sometimes I have a lot of lab time available. And the two things I do is actually walk around and then monitor remotely. So what I mean by that is I'd sit at a desk, especially my web design class, I'd sit at a desk in front, facing the students. I would open up the grade book and see how students are making progress, or you could use the real-time dashboard. Either one works. And I do real-time grading and feedback. So as they're turning in exercises, as they're doing the lab work, and if it's a teacher graded exercise, I would grade it in real time, give them feedback, say, hey, you still got some things to work on, and let them go back and deal with it there in real time. So they're getting feedback right away rather than the latent, I'll grade it tonight kind of thing. Yes, is it taxing? It sure is. But I think it's really valuable for the kids to get that feedback right away rather than wait 24 hours for it. Obviously, pair programming works as well. And, I let the kids either work independently or in pairs. It's their choice. Then finally, as an exit ticket, I use the check for understandings as an exit ticket. So, the way it's sequenced in most lessons in CodeHS is the check for understanding occurs after the video and examples and before the exercises. I move it to the end of the class and say the last 5 minutes, I want you to do a check for understanding. And I didn't use focus mode until recently. And I think I'm going to start doing this next year as a practice, which is I'm going to basically the last 5 minutes of class, I'm going to put focus mode on the check for understanding and force everybody to do the check for understanding as an exit ticket. I get maybe 75% participation in class for that. I want to get 100%. So, and that way I can understand kind of what they're getting and not getting. So the next time I see them, I can use that as part of the review. Okay. Real quickly, before I switch topics, the group debug I mentioned, here's what you do if you want to do a group debug. Create your own buggy program. Here's a Python program that I use for my principles class. Terrible program. Every line's got a bug in it, right? And what I do is I create this program in my sandbox, click the share button, then that will pop up this window. Click on both the public and show code checkboxes, click on collaborate. This window will pop up. Copy the URL that's created for you, and then go to your course overview page click on announcements and just paste the URL in the announcements. And then at the beginning of class, I'd get all that prepped as the students came in, and I'd say, okay, go to the announcements page, click on the link. Everybody's logged in and everybody sees this page. Now they can all type at the same time. I get disciplined. Like, hey, don't type until I tell you, until I let you type. Don't type until I tell you can type. And then I would ask the students, okay, find the bugs. And the first one to raise their hand, hey, line 7, the assignment's backwards. Good, you fix it. And I put the student's name in there and let them fix it live in front of everybody else, right? And somebody, line 9, the input statement should be assigned to a variable. Oh, you fix it, right? So, et cetera. And so this way they're seeing bugs and they're working collaboratively. Now, the risk is you get a lot of free riders, right? You have students that basically, same students answering the questions over and over again. Your professional teachers, you know how to deal with that, right? Try to tease out some other students to answer the questions. The other thing you can do is you can assign these sandbox programs, and I'll show you how to do that a little bit later, but you can, instead of doing it as a big group class exercise, you can make this an actual assignment exercise in your lesson. Okay. I think before I switch topics here on the grading, I'll take a pause, take a breath here. Are there any questions in the Q&A chat that I can answer now? Leah? I can't hear you, Leah.
Thank you. I think we had a question about a teacher who had taught JavaScript the first year. I think the question is, should I teach JavaScript again my second year, or it could be the follow-up progression for what would you teach after JavaScript? And I recommended Python as another choice.
Yeah.
And then I think we have another question about what is focus mode?
Oh, right. So focus mode is a new feature that came out this year where you can basically force all students to be working on the same activity at the same time. You go into, and I don't have it CodeHS up and running right now, but maybe Leah, we can get that squared away afterwards. Should we show it to them, or can we just, how do you want to do that?
Yeah, we could share a link to that. Looks like we've got a link in there already. Thank you, Sarah.
Perfect. There you go. Yeah. So it's a nice feature. You can basically force all the students to do the same activity at the same time. I would be very judicious about its use. I wouldn't make it something I do all the time. And I'll talk about that in a little bit as well. Good questions, good questions. Okay, all right, so next topic, grading and academic integrity. So here's a very busy slide, I know, but let me see if I can break this down for you. In our math department, which I'm part of, all grades are basically made up of major and minor grades. You got 70% of the score is weighted major, 30% minor. So I can get 1,000,000 points in minor grades, but still only 30%, right? And I just kind of translate that to our computer science curriculum. And the way I did that was like, look, major grades are, end of unit tests and projects that we might do. And then I said, there's some exercises that are more challenging than others. I'm going to make these major exercises. So these will be worth major points, not minor points. And the idea is to kind of give kids a chance to kind of augment poor tests with, with project-oriented or work-oriented activities. On the minor grades, it's your normal exercises, the checks for understanding, which I didn't grade for correctness. It was more completion. Did you do it or not? You get a point if you did it, right? And then on the AP kids, I assigned the AP progress checks in the AP classroom. And again, those were based on completion as well, not correctness. And so, worked out pretty well. I would teacher grade the major grades for sure. I always auto graded the minor grades. Sometimes I would teacher grade a minor grade, but usually I reserve my teacher grading for the major grades. And we'll talk about the auto grader here in a little bit. And this worked out okay. I thought it was working out okay until I discovered a major cheating ring happening, mostly in my AP courses. Especially my AP CS principles class. Actually, that was the real issue there. What was going on was, these are AP students and they're very grade savvy. The grades matter to them, right? And every point counts. And the major exercises, well, I started seeing, answers that I'm like, maybe look fishy, right? They're using functions and coding techniques that we didn't cover in class. When I looked at the code history, there was massive copy and paste to the correct answer, or they typed the answer in perfectly without any struggle, and it was turned in 5 minutes before it was due. Like, these things are kind of like, nobody programs that way. Occasionally you get your program right the first time, but usually you make a syntax error or something when you're typing it in, right? And, I do a quick search online and it's easy to show, find GitHub libraries that have CodeHS problems and so forth. So I discovered this. I pulled some students aside and said, hey, the evidence is kind of overwhelming here that you copied this is from remote sources, and most students, acknowledge that. They said, yeah, I did it. And at which point it was time to have a come to Jesus, right? Which I did with the entire class, and said, look, if we're in near the end of the first quarter, this is the basics of programming. This isn't even the hard stuff's coming second quarter. We're going to be dealing with lists and arrays, things like that. And if you have to cheat now to get through the class, maybe this isn't the class for you, right? Maybe this isn't your jam. And that's okay. It's an elective course. This isn't a required course. Nobody's forcing you to take this class, right? And so, we had that kind of adult conversation, and 6 of my 46 kids dropped the next day, which was the right decision for them, right? Which was the right decision for them. Now, what do I do going forward? Well, you can't have major exercises as a major grade because the temptation is too great. Temptation is too great to cheat. So what do? I replaced the major exercises with live programming components on tests. And I started taking advantage of the alternate exercises in CodeHS more frequently. So less chance of finding the code online. So it gets down to a real quick side. Look, all you got to do is do a quick Google search, find, answer to question 5.6 tuples or whatever, and you'll find dozens of people trying to give away the answers online. And it's like whack-a-mole. You notice this one down here, somebody shut down the repository, but if you want the answer, ping me on Instagram, I'll give it to you, I mean, so look, it's kind of, it makes it maddening. It's very maddening that people would do that, but I can't control everybody, right? So you have two options. You can be a cop or you can be a teacher, right? You spend your time investigating, which I don't want to do. I want to spend my time teaching. So it's truth or consequences. And I think you do a little both, right? If something's fishy, use the Academic Integrity Center that's available, which is wonderful. Helpful tools to discover the possible cheating, right? Oftentimes, though, you can just look at the code history and tell right away. But if you feel like students are copying off each other, this one gives you a similarity scores between student code. That's really nice. I use that feature a lot, or I used to use it a lot. I don't use it as much anymore. The consequence side of it is real simple. If we're learning how to program, guess what? You're going to get tested on the program, how to program. The default tests are multiple choice, right? So fine, we're still going to do multiple choice part of the test, but I'm going to give you a live programming task now. And what I mean by that is I'm going to give you paper instructions on something I want you to program. I'm going to give you a blank CodeHS programming exercise with no autograder. And I'm going to allow you to use OpenBook CodeHS. You can't use any other website. And I enforce that by walking around the room, right? Looking at the screens and making sure that everybody's on codehs.com and working, they can look at examples, they can look at past exercises, they can use the docs in CodeHS, but they can't Google, Stack Overflow or anything else, right? If I see them do that, they get a 0. Fortunately, nobody did that because they knew I was policing it. And lo and behold, right, students who I thought were not doing the work end up getting very low scores on the programming tasks, right? And I lost a few more that dropped after I started doing this, which is fine. I'd rather have the kids in the class that want to be in the class and want to learn how to program and focus my time and attention on them. I'm not trying to exclude people, but I want to make sure that we're doing our best, the best for the students who really want to learn. So this worked out really well, actually. It worked out really well, making a live programming assignment as part of the assessment, major grade. Okay, a word on the auto grader. Make it your friend. Yes, acknowledge that there are limitations. Occasionally you get false negatives. More frequently you get false positives, meaning the auto grader says everything's good, but there's still a problem with what the student coded. Sometimes you get misleading messages. Not very often, but occasionally that happens, especially if the auto grader has a solution that they're testing or checking out, and sometimes you get a message from the auto grader that shows some error, and the student's like, what are they talking about? I don't know, I didn't, that's not in the check code that I have. And you're like, yeah, well, the auto grader is checking other conditions that you didn't check or that they didn't talk about in the instructions, and you have to kind of walk through it with the kids. So, number one rule is don't badmouth the auto grader. Think of it as a TA, right? A teaching assistant. It's helping you out, right? And sometimes you let the TA grade the assignment, and sometimes the TA takes the first pass, then you take the second pass. And I would tell the students that, say, look, this exercise, you got to get through the auto grader, but then you got to get through the Mr. Reinke grader, right? I'm going to grade it after the auto grader grades it, and then you'll get feedback from me. And you may, if the auto grader says it's good, I may say it's good, you may be all great, or the auto grader might say it's good, and I may kick it back to you and say, hey, you still got a few things you need to fix, right? And here's some tips. The one thing I would say is you got to proactively find those students who are going on the wrong path due to misleading autograder messages. So students will go down these rat holes and not tell you about it. So you have to kind of go tease that out, right? You know, if you see somebody struggling and there's tools to see how long they're taking on different exercises and so forth, you can see that and kind of go ask, hey, what's going on here? And then you can see, oh, they're struggling with some cryptic message from the autograder, and you can help them understand that. But the one thing I would tell you would be proactive about this is, before you assign the exercise, before the lesson goes on, do the exercise yourself and try to game the autograder. Try to take shortcuts. Think like a student. How might I do this problem more easily to get the autograder to say yes? Because it becomes like a little video game for the kids, right? I can get all green check boxes, I'm done, right? And even if the code isn't quite right. And so you got to figure out how to game the autograder. And if you find you can game the autograder pretty easily, then you're going to want to teacher grade that exercise, even if it's a minor exercise. And again, of course, I always have at least one teacher graded exercise per lesson, just to make sure that I'm checking in on the kids and making sure they're making progress, understand the concepts of the lesson. All right, before I move into the curriculum, let's take another breath here. We got about 15 minutes left. Leah, any other questions for me in the QA?
Not at the moment. We've had a couple float in the chat area, but we have answered those. They talk. One question was about the relevancy of Java. And we talked about that as not as widely used as JavaScript and Python, but it is still a relevant and used language.
Yeah, I would say, you know, from the industry perspective, the two behemoths in the industry are Python and Java. And obviously JavaScript is kind of a, you know, very similar to Java, obviously. But if you're going to have a student that wants to be a professional software developer, right? Like they're moving down the path towards developing application software, system software, they need to know Java. If you're having a student that's going to be more heading towards the business information systems, you know, working in IT departments of business, they need to know Python. JavaScript is useful as well. I've made a conscious decision in our curriculum to focus on Python and Java as the key languages. I think if you learn those languages, you can pick up JavaScript pretty quickly. If I was to teach a second semester of web design, as opposed or web development, I should say, right now I'm teaching web design, which is just HTML and CSS. If I was going to do another semester of that, I would make a second semester be JavaScript, where we're using JavaScript in the context of building web applications. But you know, we just don't have enough bandwidth for that, so we're not doing that at this point. But yeah, that'd be my recommendation. Okay, so that's actually a perfect lead-in for our curriculum pathway here. So this is the current pathway that my high school uses, and it's a very good pathway. Like I said, we had 100 students signed up for computer science this year. We have both AP courses, CSA and CS principles there in the normal sequence. And then we have this course called Intro to CS, which is really web design. It's not named properly. It just teaches HTML and CSS. It's a semester course. And we have a prerequisite that says, in order to take some CS principles, either you have to pass Intro to CS, or you have to be enrolled in honors math. You have to be a sophomore or higher enrolled in honors math. And what I found was a lot of my kids that were struggling in CS principles, a lot of kids that dropped actually, were not in honors math and had taken the web design course previously and were just not prepared to think algorithmically and procedurally. It's a different muscle, right? Authoring documents in HTML is a different skill set than actually thinking algorithmically and computationally to build programs. It's just a different way of thinking about things. And just because you can author a web page doesn't mean you can actually program a computer in terms of a procedural programming language like Python. So we wanted to change this up a little bit and create a new curriculum that enabled us to have better prereqs for principals. And we had sophomores that took principals as sophomores. We have juniors, they took CSA as a junior, and now they're done. There's nothing for them to take. And we wanted to provide another course for them to take as a senior that might lead them more towards the business IT side of things, right? As opposed to the systems programming side of things. So something more aligned with if you were to go to a college in the business school and take information systems or computing information systems or information technology major in the business school. So we added a course on data science, right? So here's the new pathway we start for next year. And based on the early enrollment numbers, I'm like somebody, a very, very busy man. I may have to work a little overtime here to teach all these classes, but we changed the intro class, the prereq for principals, to be an intro to programming class. And we're focusing on Python there. We talked about using JavaScript and then Python. I said, no, let's keep it Python. Let's keep it straightforward. Yes, that means there's a little bit of overlap between that and the first semester of principles. That's okay. The intro to programming class is geared for any student, whether they're in honors math or not. By the way, the honors math thing, I did do some data-driven approach to this. I looked at the grades my students had, whether they enrolled in honors math or not, and there was a direct correlation between success in principals and whether or not they were in honors math. It was stark, very stark. So I felt we needed to get an on-ramp for kids who are not in honors math to be able to do programming. And this semester, Introduction to Programming, is a great way to do that, I believe. We'll see next year. Also, it gives us a chance for a student just wants to get a taste of programming. They don't have a full year to dedicate for this elective. They can take a semester class on programming now and get a taste of it. So I think that it serves two purposes there. The second thing is the intro to CS class we had is now properly named. It's now web design. It's off to its side. It's just a semester class you can take to learn how to author websites. And I think there's interest is still very strong in that, even though we kind of took it out of the prerequisite path. And then lastly, and this is kind of my baby, is the data science. That was my expertise, and especially in industry, was around analytics and data science. So I thought, what better topic to teach in high school than something I know and really, really enjoy. So that's a semester course. CodeHS has it. It's a wonderful class, Python based. So you need to take a Python course to get there. So that's why Principles is a prereq. And it's an honors class because kids who are taking this are going to be thinking about, I don't want to have a non-honors class to hurt my GPA, that kind of stuff. So we're going to honors up the data science piece class curriculum that CodeHS provides with some maybe extra projects or whatnot. Anyways, and it also provides a nice pathway for students who may not want to be a CS major in college, but maybe want a minor in CS, right? If let's say you want to learn economics with CS, or you want to do sociology with CS, or psychology with CS, the point of intersection is data science. That's the point of intersection. So I think this is a great course for kids to get introduced to at this level who are thinking about that kind of path. So we'll see how this goes, but this is our path for next year. And like I said, we're real excited about the early enrollment numbers. Okay, any questions on the curriculum pathways before I move on to the last topic?
Yeah, Dave, we have a great question in the Q&A. Deborah Hunt says, in the past, my school has offered C++. Is that language still relevant, or should we drop it in the future? What are your thoughts on that?
That's a great question. C++ is still relevant, but it's more systems level programming. You're going to see C++ in Silicon Valley and low level. If you're going to go work for a software company, you might do C++. It's a challenging language, especially for a high schooler. Boy, oh boy, Java's hard enough, and to add in all the extra stuff with the memory allocations and the pointers and all this stuff in C++, it's taken me way back. I haven't had, I've been in the industry for 30 years. I wrote C++ code maybe the first 5 years of my work, and the last 25, it was all Java and Python. So, now I was on the business side. I wasn't working in Silicon Valley, developing system software. And if you're in Silicon Valley, you're probably going to be doing more. You'll see more C++. But I would, if given the choice, I would recommend Java. Is probably it's more ubiquitous and gives the kids more pathways to explore. Yeah, leave C++ for college. That's a tough language. Any other questions, Leah?
Oh, that's it for now. Thank you.
Okay, great. All right, so my last section here is kind of the features I used and things I'm setting aside. So the AI feature, really nice. You can go into the conversation, any exercise, and have it generate the hint, and the AI tool embedded in CodeHS will look at the code the kid wrote and give you, hey, it's great, or no, this is what's wrong, or so forth. And I find that it's correct 75% of the time, 2/3 of the time. Sometimes you got to really look at it. Sometimes it's like, nope, that's not the problem, right? Or it's like, maybe you didn't read the exercise, the AI didn't understand what the exercise was trying to do, or something like that. So you got to give it a little slack. But I found it the most useful for my web design class. For my Python and Java classes, I can typically find the bugs just because that's my background programming. I'm the AI, I guess, but for web design, it's so picky with the HTML and CSS. You miss a character here or there and things don't show up just right. And so the AI was very, very useful for finding issues with my web design course. Now, the one thing I would like better would be for the AI hint generator to be in the grading comments, not in the conversation comments. I find myself going in the conversation, running the AI thing, and then copy and pasting and then modifying in the grading comments, because my kids typically we interact based on them submitting and me grading, versus being proactive and having conversations outside of the path. Just more of a kind of a work pattern we've established with my kids. But again, the tool is useful for finding bugs. But again, double check, make sure it's actually finding the bug you think it's finding. The other thing that a useful feature is forking, which is basically making a copy and modifying, right? Forking is a technical term, fork code. But basically, forking unit quizzes is something I did quite frequently. I find that the end of unit quizzes or tests for APCSA are pretty challenging, pretty difficult. Even my top students were struggling with them. And when I started noticing that, I realized that some of the level of knowledge in some of these questions was pretty advanced. And so I find myself forking quizzes almost all the time now, removing questions, replacing them, rewording them, to make them clear, changing some of the multiple choice answers, either to make them a little bit less ambiguous or make it more clear as to which the right answer is, or maybe for an easier question, making another answer be more challenging. So again, I do this every single time, pretty much every quiz I'm forking. I think after the first quarter, I don't think I used the quiz out of the box with CodeHS. Now, that said, I wasn't doing wholesale changes. It was still 80% what CodeHS provided. I would just maybe change maybe about 10 or 20% in the ways I just described here. The instructions for exercises. So you can fork exercises and rewrite the instructions if you'd like. If you rewrite the goal of the exercise, now the autograder might not work, so be careful with that. But what I found most useful, as opposed to forking the exercises, if you go into advanced settings, there's an extra description you can put in there. And if you type in that extra description, it shows up at the very end of the assignment instructions. And I usually put in like, this is from Mr. Ranke, and then boom. And so my students learned, hey, read the instructions and make sure you go down the end. And if there's any extra hints coming from me, they'll be there, or special instructions coming from me. I might say, look, in order to get by the autograder, you got to make sure that your print has an exclamation point at the end. If it doesn't, the autograder is going to say no, right? You know, little things that they're going to trip little kids up, right? Because they get the autograder can be very picky. It's like looking for specific text in the output. And the student might write the right program and everything's correct, but the print statement's missing a period or something, and the autograder says no. So you got, sometimes they give them hints saying, look, the autograder is real picky on this one, be careful. Or in this example, the Fibonacci, some of the kids are not familiar with the Fibonacci sequence. So you got to say, look, the first sequence starts with 2 1s. So make 2 variables, one for each one, and then et cetera. You give them a little help to get them moved along here in terms of solving the problem. Use this quite frequently. Pushing sandbox programs to lessons. I use this more in the second semester as I kind of got more familiar with it. The idea here is you can build your own program, for example, the debug programs I was talking about earlier, and you can push them out. You can share them by just sharing the program from the sandbox and then assigning it. And you'll see down here at the bottom here, you can assign it as an example or as an exercise. And you assign it to the course, then you gotta go find it, move it into the proper lesson. That's a little bit of pain, but it's not that big a deal. But the bottom line is that you can create your own problems. Now you're gonna have to teach again. There's no autograder unless you want to dig and learn the autograder, which I advise against. It's kind of challenging, kind of complicated. But I did this to create custom exercises and custom examples, and especially on the debugging side. I know CodeHS is working on more debugging type activities in the next year. Hopefully I see more of those going forward, but I started creating some of my own. Sometimes the best way to learn how to program is to fix programs, right? Use of ChatGPT. Boy, this is really useful, especially if you're forking quizzes and tests. And if you find that you're concerned that students are finding answers to quizzes and tests online, right? Which I'm sure they can. So you can basically cut and paste. You can say, on the left-hand side is an example prompt. Suppose you're an APCSA teacher, provided a similar question with the answer for, and cut and paste the question right out of the test and put in, and ChatGPT will respond. In this case, it was real simple. They basically changed the name of the method from add numbers to calculate sum. Now I would have changed up the ordering of the ABCD so that the answer is a little different. It's not B in both cases, but you can do that on your own. But with very little prompting, you can ask ChatGPT to generate questions for you. For example, I had to do a final exam now for my principal's class. I was preparing for it, and I wanted to have a question on the digital divide, right? A concept of inequity because of computing. And I said, I gave a very vague prompt to ChatGPT. Suppose I'm a APCS principles teacher. I need a multiple choice question on the concept of digital divide. And the first response came back from ChatGPT was perfect. It was great. And I use that. And so you can even be that vague and get great questions for tests if you want to go off-road. So I use AI quite frequently to help me create test problems. The Parsons puzzles. Dave Kleinhans shared this concept with me late in the first semester, and I wish he had shared it with me before the semester started, but I'm sharing with you now. The Parsons puzzles are great. What you'll find with students is the syntax, they eventually figure out the syntax. It's the algorithms they struggle with. When do I use a loop? How do I do nested loops? Should I put the if statement inside the loop, or should I put the loop inside the if statement? Those kinds of things, right? Thinking algorithmically about how to solve these computational problems is a challenge. And Parsons puzzles are designed for that. It takes syntax out of it, right? It takes syntax away. It's like sequence these lines of code in the right sequence and with the right indentation so that everything's embedded properly. It's good for Python. Actually, it's just for Python. And I started using these things, and you can actually embed them into CodeHS pretty simply. You go to that URL that's on the page there, create your own program puzzle. And then basically you can copy the add new assignment in CodeHS and copy the link from the URL for the puzzle into the assignment, and it'll be an article. It'll be an article, so you can't really grade it, but you can challenge the kids with that. And so this is another one you might use focus mode for, right? Throw it out there as an article. Okay, everybody's doing 3, 2, 7 and debug, and then walk around the room and see how they're doing, right? So if you haven't seen these Parsons puzzles before, go explore it. A very useful tool, especially if you're teaching Python. Last slide. Just in time too, I think. We got 2 minutes left. Features I'm setting aside for the future. Focus mode. Students tend to work at their own pace. And so I was using it, and my advanced students, I heard a lot of complaining and legitimate complaining. They couldn't move forward. They finished the exercise and they had to sit and wait for everybody else to finish. They didn't like that. So I'd be very judicious with focus mode. Copy paste prevention, don't really use it. Why? You can't copy and paste within the editor if you do that, which is kind of painful because sometimes you do want to copy and paste within your own code. And the second is students are very willing to type copied answers in from the internet source. Trust me, they'll do that. I already talked about the end of unit quizzes. I would not use the online version of that. I use printout versions of the end of unit quizzes. Why? Because of absent students. I have a testing center for makeup quizzes. I don't want to train my testing center person to turn on the quiz for the student and turn it off when they're done and all that stuff. It gets too complicated. So I use paper quizzes and do paper security for my tests. And then the badges, I thought this would be a really cool thing. I started creating all these fun little badges to give the kids, and it just didn't catch on. The kids were like, yeah, whatever. So it was a lot of effort for not much benefit. So I'm not really going to do much custom badging next year. I think that is it. It's survey time. Leah, you want to take over here?
Absolutely. Well, first, Dave, that was an amazing session for first-year teachers. It just chock full of so many good tips from you personally in the classroom, and then also leveraging the platform for teachers. So thank you so much. If we could all do a round of applause, you can do it with the emotions or the reactions, or you can just show on your screen. Dave, that was fabulous. Thank you. Thank you so much. And never fear, everything that Dave just discussed, we will have a recording and the slides, and all of that will be sent out to all of you and actually everyone who participates in the conference. Dave mentioned the survey. When you pop back out into the lobby, you'll see a prompt that asks you to fill out the survey. And when you fill that out, you will be receiving the swag bag that was talked about in the intro session. So with that, we'll close this session and then pop back into lobby and choose your next session. If you need a quick break, you've got time for that as well. But thank you so much for joining us today. And thank you again, Dave, for this amazing presentation. Thanks to Mark for supporting us. And I hope you all enjoy the rest of the conference.
Yeah, thank you, everyone. Thank you so much.